everybody, it's Neil Harrison with Western Canadian Rockwell. I'm just putting together this little tech video for True Bogger magazine. We're coming at you up here in Canada, land of the hockey sticks and maple syrup. Today we're going to do a little video on these Meritor hubs the guys are getting familiar with. They've been around for a while, but they've just recently come into the mud bogger off-road market. So we're just kind of going to give a little rundown how they all work, how everything works, how to put them together, how to take them apart, and we'll go from there. We're not going to get further than the hubs. We're not going to get into the knuckles or the complete axles because there's quite a bit to cover on just the hubs. So we'll start there. So to start off, I've got a Meritor hub here. It's completely tore down. You can see every little part and piece is broke down, so you can see it completely disassembled. We'll kind of just go through each part and piece here. This is obviously the hub. You can see that these things from the factory, they come with a central tire inflation system. You can see here, this is the line that feeds through here, feeds air out the one wheel stud, and it comes in through this fitting here. And what it does is it has two high pressure seals inside that run on the spindle. The spindle has a hole here that feeds air through there. That's basically how it all works. Two seals seal there and there. This is the hub seal. I'm going to go over this in a little better detail in a second. We'll come back to it. Hub bearings. This is your spindle nut. You know, very common, same as a 2.5 ton. But this is when it gets a little more complicated. Is these are a lot of guys call them a planetary hub. They're actually known as a bevel gear reduction hub. So basically, it looks the same as like a differential assembly from a rear end of a pickup truck. This is the shims used to shim the gears together to set the backlash on everything. This is your inner gear, spider gear setup. The outer gear, your axle shaft splines into that, and this is your outer hub. Probably familiar with that piece. And these are the thrust bearings for the hub. This is spider gear assembly. It's a lot different than what you'd find in a pickup truck. Most pickup trucks in the rear end, it's just steel on steel. There's no actual bearings. So these are a little more reliable. There's the needle bearing there. Outer thrust plate. You can see here with a thrust bearing assembly and a little wear washer that goes on there. And then an O-ring that seals on the end of the cross. Just seals in this part here. Okay, so I'm just going to touch on these seals on the Meritor hubs. These are actually a fairly common seal on the newer axles. Axletechs use the same sort of idea. And what it's known as is a companion seal. And how this works is we have basically a typical oil seal here. You can see this one just has a lip with a spring behind it. I don't know if you can see that, if you can get in close enough. But basically this lip rides right on the wear surface of the spindle. And over time it'll cause a little lip, a little wear groove, and they'll leak. You have to put a speedy sleeve on it or something like that. Whereas these companion seals, this outer edge presses into the hub, and this rubber seal seals on the spindle, but it's actually a two-piece. So as you can see here, the inner piece spins inside the outer piece, meaning that the only part that wears is actual seal itself. So when you replace this, you replace everything. So there's no wear on the hub, no wear on the spindle, and it actually seals quite a bit better. These aren't like the old Rockwell seals that'll leak water and stuff, and they'll last a long time. So I just wanted to kind of cover that. Alright, now we're going to do a teardown on this Meritor hub. This one's already been disassembled, so it'll come apart a little easier than it would if it was already in service. Basically pull out your ring of bolts. They just require a 9/16 socket to pull them out. Pop the cap off. Usually it's a silicone that's sealed this, so it'll take a little bit of force to get it broke loose. Once it's apart, make sure you grab your thrust washer and the backing plate. It can go in there. This is your outer gear. Obviously this one's on the bench, so there's no axle shaft in it. You'll typically see an axle shaft here. A front assembly won't use a snap ring, but a rear will. So be prepared if you need snap ring pliers to pull that snap ring off. So outer gear will come out. The spider gear cross, usually it's got some silicone underneath of it too. so it can be a little tough to get out of there. Sometimes you got to take a pry bar just to break it free. It'll come out. This is the backside gear. It'll slide out of there. Set it on top of here. Got your shims for adjusting the preload. Go on there. And then you have basically your spindle nut. And what we've been using for a sock is just a homemade jobby with a piece of pipe welded in between, laser cut. It works pretty good. I haven't really found, and I guess I haven't really looked too hard for an off-the-shelf one from Napa or wherever, but you will need something that's fairly deep, because once this is installed in the vehicle, on a front assembly you have the shaft sticking out quite a ways, so you have to make sure the socket will fit over everything in order to break that loose. So take that off. And then this one I've already popped the seal out of the back side of it, so it'll come apart pretty easy. But these companion seals do have a pretty tight fit, and what you're going to want to do is make sure that the outside stays in the hub and you pry off the inner diameter off the spindle. So it's best to kind of get back in between here with a little bar and kind of gently work it. And as long as everything's true to each other and it doesn't cock sideways, it should slide off there with just a slight bit of pressure. If it gets jammed up and tight to pull off of there, slam it back on, give it a good push so it seats itself again, and then try working it off again. And it should come. If you fight with it or you get rammy, you're probably going to wreck the seal. You'll end up bending the outer diameter and it's not going to seal up very well. So just kind of be careful with that. Once you pull this apart, you got 2 bearings, and that's about that. Now we're going to kind of get into some of the things. A lot of these hubs are new surplus, so there's nothing really to worry about. They're brand new. But if you end up with some used stuff, we're going to kind of go over some of the things to look there. These obviously aren't an old Rockwell axle where if you drop a bearing or a part in a mud puddle, you can just rinse it off on your shirt, throw it back together, and it's fine. These things have a lot of little intricate pieces that have to be kept very clean and set up properly. And if there's any wear or anything like that, they can fail and cost you a lot of money. Okay, so we got this disassembled. Obviously we're going to start off, give everything an inspection. Same as anything, you want to make sure your bearings don't have any flaking or wear on them. As long as they're good, you can reuse them. The other thing you have to keep in mind is all these little rotating parts inside here. They're spinning at double the speed of the entire axle, so they're moving pretty quick. And if they lose lubrication or they get hot or full of dirt or wear items like piled up bearings and stuff like that, they'll wear out pretty quick. You can see this gear here, it's seen a little bit of wear on it on the tooth face here, so it's taken a bit of damage. The other thing you got to watch too is all these little needle bearings that are in here. If they start to fail, they can pile up pretty quick. These little thrust bearings and stuff like that. This one here, it's actually taken on a little bit of surface rust. You can see the bearing, the rollers in the bearing there have got some corrosion on them. And what that's done is basically corroded away the hard surfacing on the bearing, and it's not going to last too long. Same with the back side of the gear, this one that fits here. You can see it's taken some corrosion there, and it's not all that healthy. And same with these little thrust washers that sit behind the bearing. It's taken some corrosion, and it's going to wear out pretty fast too, and you don't really want that to fail. If it does, it's going to fill that entire hub full of metal shavings, and you're going to have to pull everything apart, clean it up. As even if you catch it in time, if you don't, it's going to wreck a whole bunch of other stuff, and things are going to get fairly expensive. So just kind of keep that in mind. Okay, so what you're going to need to set up this planetary hub to set the backlash in the gears is, first off, what you want to do is torque down your spindle nut in here to 10 to 20 foot-pounds. Not very a lot. You can use your spindle nut socket, torque that down. This has already been done. And then what you want to do is you're going to need a straight edge, a caliper, and if you're like me, probably a calculator to figure all this out too. What I found works pretty good is you put 2 hub bolts in here, drop your straight edge on top of it, And as it shows in the manual, run your caliper in from this face on the hub down to the face of the spindle nut. That's what we're going to do there. Keep everything nice and straight. You can see here's our measurement. And we are at 3.699. So I'm going to write that down. And then because we're measuring from this surface, I'm going to have to subtract the width of my straight edge, which is 1.475. So is 2.224, and the tolerance we're looking for here is between 2.168 and 2.173 between this face and the spindle nut socket. And how we're going to make up that difference is with these shims. So if we subtract 2.224 minus 2.168, we're looking at 0.056 worth of shims. And what I've done here is I've already measured up these shims. I got a 15 thou, a 20 thou, and a 20 thou. So if we add those all together, we've got 55 thou. So if we minus that, minus our 2.224, we're sitting at 2.169, which is just a hair over 2.168. That puts us right into spec. So we're perfect. So I'll show you how to put all this back together now that we've figured out what we need for shims. Okay, so this is the part that usually drives everybody crazy. What you've got here is 2 holes in your backside gear and then 2 pins, and you have to line everything up, including the splines and the splines in here and these 2 pins. So what you're going to want to do is get yourself a paint pen. This is my favorite salmon colored paint pen, and just mark these holes with the spline, run it down so you can see where it's at. I've got that spline marked, and then you're going to want to get in here and mark this where the pin is sitting in the spline, and basically line everything up, and it should drop in fairly easily. Sometimes it doesn't, sometimes it can be a little bit of a bear. What you can do is, if you need to, I just use like the backside of a screwdriver, just something soft, give it a little tap, and sometimes it'll drop in. Definitely don't get rammy. If it doesn't drop right in, pull it back out. You can turn the nut a slight bit. It actually says this in the manual. So do not loosen the nut more than 1 spline tooth from the initial torque setting of 10 to 20 foot-pounds. So if you need to, you can play with it a little bit. You just can't go too far. So keep that in mind. And eventually it will go. Okay, here's a cross assembly. Sometimes it can be a little tough to get in there. You're gonna make sure these plates are properly lined up. If it won't drop in, give the gears a little bit of a wiggle. Once everything's seated properly, run a thin bead of silicone along these edges, clean your bolts up, clean your bolt holes up. Make sure you clean up the back side of this. Put your axle shaft in, drop your outer gear on it. Make sure both your needle bearing and the backing plate are inside of here. And you can drop this on top. Make sure everything stays in place when you do. Obviously this one didn't. Sometimes a little bit of grease will help hold that in place. Drop it on, torque your bolts down, and then basically to fill it with oil is you want to make sure that your drain plug, once this is sitting horizontal, is at either the 4 o'clock position. Fill it with oil, and give it a good rotation, make sure it's up to level, and you're ready to roll. Okay, there's just a couple other little points I wanted to touch on here. A lot of guys are mismatching parts and stuff like that. If you end up finding a rear Meritor axle, usually they're quite a bit cheaper than the front ones, and you want to use it in a front application with stub shafts, the thing you have to keep in mind is the rear spindles, they don't run, like the factory doesn't install these bronze bushings to support the stub shaft, and there's also a thin steel thrust washer that sits in here. The rear spindles won't have that. So before you put it into a front application, you have to make sure that you add those parts and pieces, or your spindle's gonna, or your stub shaft's gonna flop around inside of there. The other thing to keep in mind, and it's not a huge thing for the off-road guys, but I just wanted to kind of point it out, is the rear axles, they have the port for the central tire inflation, but they don't have this second vent port here. And basically what it does is it comes through here and allows the hub to vent. And this is basically if you're using it on the highway and you're building up a lot of heat in the hub, you need somewhere for that excess pressure to go. And if you don't, it's probably going to start weeping out of this stub shaft seal. It's not a big deal for the off-road guys because we're not using them long enough or hard enough to create a bunch of heat in the hub, but it's just something to keep in mind. If you think you're going to use it on the highway, probably best to go with a front spindle assembly, or I'm sure you could get a qualified machine shop to add that vent port into a rear spindle for you. Okay. Earlier in the video we went over these central tire inflation seals. One thing I was going to mention is if you don't plan on using the central tire inflation, it's a good idea to pull these things out of here. You can see there's a snap ring down in there, just a flat blade screwdriver will pop that out of there. Remove both these seals and then flood the hub with oil. What that does is if you don't, what you have to do is pull out this outer seal and repack this bearing with grease, as the oil from the other side of the hub won't make it past the central tire inflation seals, and eventually you'll have to repack that. Okay, the last thing I wanted to touch on was these axle tube seals. They're the same seal for the spindle and the ones that fit into the inner axle housing, and they fit here on the outside of the stub shaft and the inner axle shaft. And the issue that I've run into a couple times is that the first time you see these, it looks like one complete seal. It doesn't look like anything comes apart on these things. And what's happened is guys will press these in, go to slide in their old axle shaft, and it won't go, mainly because this piece is still stuck on here. Without realizing it, they're actually a two-piece seal, and this inner part is what's still stuck on the axle shaft. So basically what you got to do is either peel that off of there and the axle shaft will slide into this new section, or what you can do is take this piece off, throw it away. If this is still in good shape, reuse it and just press in the outer part. That's all I want to touch on. Thanks for watching, guys. I appreciate Bogger inviting us to put this video together. Hope you guys enjoyed it. Thanks.